Hello my dear wonderful genius students, I welcome all of you to my YouTube channel. This is lecture number 25 on complex analysis, and in this video I am going to solve some numerical problems by using Laurent's theorem. But before solving numerical problems, let me review what we had learned in the last lecture. Students, in my last lecture I told you that with the help of Laurent's theorem we can expand a function f of z about a singular point z equal to a in this way. F of z is equal to summation n goes from 0 to infinity a n into z minus a whole to the power n plus summation n goes from 1 to infinity b n divided by z minus a whole to the power n. Here a n is equal to 1 by twice pi iota integration along curve C1 f of w divided by w minus a whole to the power n plus 1 into dw, and bn is equal to 1 by twice pi iota integration along curve C2 f of w divided by w minus a whole to the power minus n plus 1 into dw. Here the first part is known as the analytic part and the second part is known as the principal part. So we have seen that the analytic part contains the terms having positive powers of z, and the principal part contains the terms having negative powers of z. Next, মই এটা very controversial statement দিছো, আৰু সেই statementটো হৈছে never use this definition to expand a function about a singular point. Always use binomial theorem to expand a function about a singular point. So, এতিয়া কুৱেশ্যনটো আহিলে যে আমি কিয় এই থিওৰেমটো পঢ়িলো লগতে ডেৰিভেশ্যনটো কৰিলো। মোৰ আনসাৰটো হৈছে এইটো সিলেবাছত আছে, লগতে কেতিয়াবা কি হয় এক্সামত থিওৰেমটো লগতে ডেৰিভেশ্যনটো সোধে। So tar bahire ei theorem to kono relevance nai. So ami always expand korim a function about a singular point with the help of binomial theorem only. Now let me solve the numerical problems. The problem number 1 says we have to expand the function f of z in the Laurent series in 4 different regions. Region number 1 is modulus of z less than 1. Region number 2 is modulus of z greater than 3. Region number 3 is modulus of z in between 1 and 3, and the region number 4 is modulus of z plus 1 in between 0 and 2. Now let me solve problem number 1a. So solution to problem number 1a. So according to this problem we have to expand this function in the region modulus of z less than 1. That means within this region we have to expand the function f of z. So according to the problem, f of z is equal to 1 by z plus 1 into z plus 3. Our first target is to resolve this term into partial fraction by using partial fraction method. Now let us resolve this term into partial fraction here. So 1 by z plus 1 into z plus 3 can be written as a divided by z plus 1 plus b divided by z plus 3. Now let us multiply both sides of this equation by z plus 1 into z plus 3. So the left hand side will become 1 and the right hand side will become a into z plus 3 plus b into z plus 1. Next we have to find out the value of a and b from this equation. So when z equal to minus 3, then b will be, so this part will be cancelled out and b into minus 3 plus 1 minus 2, so therefore b will be minus half. Again when z equal to minus 1, then this part will be cancelled out, so minus 1 means plus 2, so a will be equal to 1 by 2. So finally we have seen that 1 by z plus 1 into z plus 3 is equal to half divided by z plus 1 plus minus half divided by z plus 3. So, this one can be written as 1 by 2 into 1 by z plus 1 minus 1 by z plus 3. So, after resolving into partial fraction, this term can be written as 1 by 2 into 1 by z plus 1 minus 1 by z plus 3. Next, let us convert this term and this term to this form 1 plus x whole to the power minus 1, where the first term has to be 1 and the second term has to be less than 1. So, let us do. So, this first term can be written as 1 by 2 into 1 plus z whole to the power minus 1. So, here the first term is 1 and the second term is less than 1, because according to problem number 1a, the value of modulus of z is less than 1. Again, let us simplify second term. So, first let us take common 3 from the denominator of this term. So, if we take common 3, we will get 1 plus z by 3. So, here the first term is 1 and the second term is less than 1, because the value of z is less than 1. So, less than 1 divided by 3 is obviously less than 1. So, finally, we get f of z is equal to 1 by 2 into 1 plus z whole to the power minus 1 minus 1 by 2 into 1 by 3, 1 by 6 minus 1 by 6 into 1 plus z divided by 3 whole to the power minus 1. Next, let us apply binomial theorem to expand this term and this term. So, finally, we will get 1 by 2 into 1 minus z plus z square minus z cube plus dot dot dot. Next, let us expand this term by using binomial theorem. So, finally, we will get minus 1 by 6 into 1 minus z by 3 plus z square divided by 9 minus z cube divided by 27 plus dot dot dot. Now, let us add same power terms. So, first let us add this one and this one. So, 1 by 2 minus 1 by 6 plus again let us add this one and this one. So, minus z by 2 plus z by 18 plus let us add this one and this one. So, we will get z square by 2 minus z square by 54. Again let us add this one and this one. So, minus z cube by 2 plus z cube divided by 27 into 6, 162, 162 plus dot dot dot. First, let us simplify this term. After simplifying, we will get 1 by 3. Again, after simplifying this term, we will get minus 4 by 9 into z. Again, after simplifying this term, we will get 13 divided by 27 z square. Again, after simplifying this term, we will get minus 40 divided by 81 into z cube plus dot dot dot, which is the required expansion. Which is the required expansion. Next, okay, let me solve the problem number 1b. According to this problem, we have to expand this function in the region modulus of z greater than 3. That means, for this problem, we need to expand this function outside this circle whose radius is 3 and the center is located at the point z equal to 0. So, the expansion has to be done outside this circle. Okay? For this problem, the procedure is same up to this step. However, we cannot write this term in this way and this term in this way, because if we write, then the second term becomes greater than 1, because according to this problem modulus of z is greater than 3. For this case, we have to take common z from the denominator of this term and this term. So, finally, we will get 1 by 2 into 1 by z into 1 plus 1 by z minus 1 by z into 1 plus 3 by z. Here the first term is 1 and the second term is less than 1, because according to problem number 1b, the value of modulus of z is greater than 3. So, 1 divided by greater than 3 is obviously less than 1. Again, for this case also this term is less than 1. So, finally, we can write f of z is equal to 1 by twice z into 1 plus 1 by z whole to the power minus 1. Next term minus 1 by twice z into 1 plus 3 by z whole to the power minus 1. Again, let us expand this term and this term by using binomial theorem. So, finally, we will get 1 by twice z into 1 minus 1 by z plus 1 by z square minus 1 by z cube plus dot 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 minus. Again, apply binomial theorem to this term. So, finally, we will get minus 2 by z into 1 minus 3 by z plus 9 divided by z square minus 27 divided by z cube plus dot dot dot. Again, let us add the same power terms. First, let us add this term and this term. So, 1 by twice z minus 1 by twice z plus, again let us add this one and this one. So, minus 1 by twice z square plus 3 by 2 z square. Next, add this term and this term, plus 1 by twice z cube minus 9 by twice z cube plus, again let us add this term and this term. So, finally, we will get minus 1 by twice into z to the power 4 plus 27 divided by 2 z to the power 4 plus dot dot dot. Next, let us add this term, this term, this term and this term separately. If we add this term, we will get 0. If we add this term, we will get 1 by z square. Again, if we add this term, we will get minus 4 by z cube. Again, if we add this term, we will get 13 by z to the power 4 minus dot dot dot, which is the required expansion. Next, let me solve problem number 1C. According to this problem, we have to expand this function in the region modulus of z in between 1 and 3. That means for this problem, we need to expand this function within this annular region formed by two concentric circles of radii 1 and 3 having center at z equal to 0. Students, for this problem also the procedure is same up to this step. After this step, we have to take common z from the denominator of the first term and 3 from the denominator of the second term. So, let us do 1 by 2 into 1 by z into 1 plus 1 by z minus 1 by 3 into 1 plus z by 3 bracket close. Now, let us check whether the two conditions are satisfied or not. For this part, the first term is 1 and the second term is less than 1 because according to this problem, for this region the value of modulus of z is greater than 1. So, therefore, 1 divided by greater than 1 is obviously less than 1. Again, for this term, the first term is 1 and second term is less than 1 because for this region the value of modulus of z is greater than 3. So, therefore, greater than 3 divided by 3 is obviously less than 1. So, finally, we can write f of z is equal to 1 by twice z into 1 plus 1 by z whole to the power minus 1 minus 1 by 2 into 1 by 3 1 by 6 1 by 6 into 1 plus z divided by 3 whole to the power minus 1. Next, apply binomial theorem to expand this term and this term. So, finally, we will get 1 by twice z into 1 minus 1 by z plus 1 by z square minus 1 by z cube plus dot dot dot. Next, minus 1 by 6 into 1 minus z by 3 plus z square divided by 9 minus z cube divided by 27 plus dot dot dot. Next, let us multiply this term with this term and this term with this term. So, finally, we will get 1 by twice z minus 1 by twice z square plus 1 by twice z cube minus 1 by twice z to the power 4 plus dot 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 minus 1 by 6 plus z divided by 18 minus z square divided by 54 plus z cube divided by 162 plus dot dot dot. Here we have seen that there is no same power terms. So, finally, we will get the series as follows: minus 1 by twice z to the power 4 plus 1 by twice z cube minus 1 by twice z square plus 1 by twice z minus 1 by 6 plus z divided by 18 minus z square divided by 54 plus z cube divided by 162 plus dot dot dot, which is the required expansion, which is the required expansion. Okay. Finally, let me solve problem number 1D. according to this problem, we have to expand this function in the region modulus of z plus 1 in between 0 and 2. That means for this problem, we need to expand this function in the annular region formed by two concentric circles of radii 0 and 2 having center at z equal to minus 1. So, this is the region that we need to expand our function. Okay? Now, let me solve the problem number 1D. Students, for this problem also the procedure is same up to this step. After this step, we have to rearrange the denominator so that we will get a series as a power of z plus 1. So, let me rearrange these denominators. So, finally, we will get 1 by 2 into 1 by z plus 1 minus 1 by z plus 1 plus 2. After this step, we have to take common z plus 1 from the denominator of this term, because according to this problem, the value of modulus of z plus 1 is greater than 0. Again, we have to take common 2 from the denominator of this term, because according to this problem, the value of modulus of z plus 1 is less than 2. So, finally, we get f of z is equal to 1 by 2 into 1 by z plus 1 minus 1 by 2 into 1 plus z plus 1 divided by 2. Now, let us multiply half with this term and this term. So, finally, we will get 1 by 2 into z plus 1 minus 1 by 2 into 1 by 2. So, 1 by 4 into 1 plus z plus 1 divided by 2 whole to the power minus 1. Now, let us expand this term with the help of binomial theorem. Here, the first term is 1 and the second term is less than 1, because the value of modulus of z plus 1 is less than 2. So, less than 2 divided by 2 is obviously less than 1. Finally, we will get 1 by 2 into z plus 1 minus 1 by 4 into 1 minus z plus 1 divided by 2 plus z plus 1 divided by 2 whole square minus z plus 1 divided by 2 whole cube plus dot dot dot, bracket closed. Now, let us multiply 1 by 4 with this term. So, finally, we will get 1 by 2 into z plus 1 minus 1 by 4 plus z plus 1 divided by 8 minus z plus 1 whole square divided by 16 plus z plus 1 whole cube divided by 32 plus dot dot dot, which is the required expansion, which is the required expansion. This is all about today's video, and I hope that you have learned a lot from this video.